Okay, this problem really is two questions kind of mixed into one problem. It's a relationship reminder for Avogadro's relationship, but also to remind you that you can calculate the numbers of moles and the numbers of atoms of a particular element based on its relationship with its chemical formula. And so this is what this problem is really reminding you of. And so there's two questions. First, the first question is, how many moles of iron are in 1 mole of Fe2O3? And so it really is just having you remember that there's a relationship that it can be developed based on the chemical equation. And namely, this relationship is that there are 2 moles of iron for every 1 mole of Fe2O3. And so the basic plan is to convert mole of Fe2O3 to mole of Fe. And so we can put that together and we can do it like this. 1 mole of Fe2O3 would have 2 moles of iron. And this is just a quick problem to remind you that the relationship from a chemical equation can be used to answer problems. So you get, of course, 2 moles of iron. Now it's asking you how many iron atoms in 1 mole of Fe2O3. Now there isn't a direct relationship, but we can go from mole of Fe2O3 to mole of Fe, and from mole of Fe to the number of iron atoms. And so we're going to put it together exactly the same way as before. 1 mole of Fe2O3 times the relationship from the formula. Fe2O3 has 2 moles of iron, and now let's use Avogadro's relationship. 1 mole of Fe is 6.022 times 10 to the 23rd iron atoms. And so what do you get at the end of the day for this one? You get 1.204 times 10 to the 24 iron atoms. And so for the first one, it's just 2 moles of iron. And for the second half of the equation, it's 1.204 times 10 to the 24 moles of iron. This isn't really new in the stoichiometry chapter, but if you're doing it in earlier in the course, then this should be appropriate for that particular reminder. Again, we're just talking about how we can relate the chemical formula to the number of atoms that are in that formula. Okay.